Hello. Today we're going to be talking about music and the brain. So, before we begin, one question to ask ourselves is what brain functions might playing or singing along to music require? For me, I'm a musician. I play violin, and when I think of brain functions that might be involved in playing violin, for example, I think of muscle memory. But it's not only that. I also think of um, being able to visualize the melodies that I'm playing because I visualize that. I think of being able to feel the emotions connected to the music, to be able to express myself through the music I'm playing. And while these might seem like abstract concepts, they've actually been explained through some neuroscience research. So, some of the parts of the brain that are activated while listening to or while playing music in musicians include frontal lobes, which can be enhance an activity while listening to music. So while you're studying, if you listen to music, your thought process gets a little bit more advanced because you're listening to that music and it's activating your frontal lobes. The temporal lobes, because they process sound. Interestingly enough, Broca's area, which is an area used to produce speech, but Broca's area is activated in musicians for expression of music. So when musicians are playing an instrument or singing without even saying words, their Broca's area is activated. So it's like they're producing speech, but really it's expression. So one question we can ask ourselves is how is music like language? I think that music is pretty similar to language in that we express ourselves through different tones. We have like different chord progressions that mean different things. So music in itself is kind of like a language. There's also Wernicke's area that's activated in musicians while listening to music, and Wernicke's area is a part of the brain that understands speech. So um, while listening to music, people are understanding the expression of the music, understanding kind of the music speech. It's very interesting. The Broca and Wernicke's areas are activated because these are typically specifically only for speech, but happen in music too. There's also the occipital lobe, which is activated in some professional musicians because some professional musicians visualize the music as they play. So that also brings up the question of can we visualize music? I personally can. Music brings to thought different stories, different sceneries, and it is pretty easy to visualize music when you think about it. Um, one of the last important parts of music in the brain is the hypothalamus, which is a part of our brain that normally regulates temperature and hunger. But in music, it's being used to increase or decrease your heart rate and your breathing. And this is because music, releases chemicals in our brain that can make us maybe more anxious or give us chills. So this hypothalamus activation is kind of creating that effect of like your heart beating super fast when you're listening to an exciting part of a symphony or of a rock song. Some other interesting things that have been connected to music in the brain is specific neuron activity. So there's something called the N5 effect, where if you take a scan of the brain, there's a certain region of the brain that lights up in specific patterns only when listening to chords. So it's interesting how these specific chords that we think are normally just a human made concept chords, but they actually are activated in people's brains when you're listening to chords. So the chords kind of they fit in together, and that's what creates the concept of music for some people. And what's also interesting about this is the amplitude of the waves that you see in the brain scans. While you're recording the brain to see the N5 effect, they actually decrease when the chord sound decreases. So we have to ask ourselves, why do only musical chords generate this pattern? Is there something special about music and chords and sounds that activate a certain part of our brains when listening to it. So here's a little musical illusion, and I just want to ask you, do you think these notes are ascending or descending? It's going to be a few series of notes, and um, just kind of get down a piece of paper and a pencil and record your thoughts on whether you think these notes are ascending or descending. So what is the right answer? It's that they are both ascending and descending. And people normally only hear one or the other. It's kind of like the dress where people were debating whether it was blue or black and white and gold. Some people are arguing that it's ascending, ascending, descending, descending. I personally hear ascending, descending, ascending, ascending, but everyone hears things differently. And that's something interesting about this illusion because there's two notes being played at the same time, one of them which is getting higher, one of them which is getting lower, and we specifically cancel out one of them and hear the other one um, more than we do the first one. So it's kind of different in everyone, and one of the factors that determines or can be linked to whether we hear ascending or descending is what language or dialect that we learned at birth. So there's an interesting study in which a scientist surveyed people in California versus in Great Britain, and the Californians tended to hear more ascending pitches, whereas British people tended to hear more descending pitches. And this could be because languages are also shaped on um, different tones. So Californians may be speaking in ascending pitches more often, whereas British are speaking in descending pitches. So here's another illusion. I'm going to give off the song. This is a song from the Shrek soundtrack that you may have heard, All Star. I'm just gonna give a warning that it's not gonna sound very pretty, but this is for a reason. I want you to listen closely and see if you can hear anything else besides the piano in this song. So I personally heard a chorus of voices singing along with the song. And what's interesting about this illusion is that this piano track was created from every frequency that was in the original song. So it's almost as if the piano track was trying to imitate the voices singing along with it too. So a lot of people can hear, voices singing along with the song if they're familiar with it. They can hear all the lyrics, even though it's not there. This piano is replicating the voice, which is pretty cool. I'm gonna play it a little bit more to see if you can hear the sound. Okay, let's move on. So the last thing that we're going to talk about is our more emotional responses to music. So I want you to think about what feelings you get when listening to music. I personally feel music very intensely. If I'm listening to a happy song, that pumps me up. It gets me excited for something. Whereas when I'm listening to a sad song, I'll probably look dramatically out the window and think about all the sad moments in my life. So music has a strong emotional connection to me, and it does for a lot of people. The reasoning for this is that the body actually responds to the music you're listening to. So music a lot of times releases dopamine, and endorphins, which are two chemicals that make people happier. And endorphins specifically can release stress and pain. So sometimes when people, they do exercise while listening to music, the extra endorphins they get from listening to music on top of exercising can help them, relieve the pain that they might feel while doing it. And I know for me, that helps a lot. If I'm listening to happy tunes while I'm going on a jog, it helps me to forget about the pain that I have. Um, a last physiological response that happens when you're listening to music is your heart rate and breathing changes. And um, the body changes its own musical pattern. So your heart might be beating faster during a fast movement of a symphony, or while listening to rap music or exciting R&B, whatever music you listen to, which could give the body like chills. That's why some people would say, "Oh, that the symphony gave me chills." It is a real physiological response that comes from the body. And there's a new field, music therapy, which has been proven to work on a lot of people, specifically in memory loss patients, so Alzheimer's and dementia patients that are losing their memory. Music therapy actually works very well with them. So, music therapists will go and they'll bring instruments, they'll encourage them to play a little bit of music or to sing along. And what's interesting is that a lot of memory loss patients actually remember the words to their favorite songs or how to play instruments if they learned when they were younger, because music is more of a procedural memory that doesn't get lost with their disease. Another thing that therapy helps for is Parkinson's patients. Parkinson's is when the brain kind of loses its dopamine. So people will not have too much control over their muscle movements due to that lack of dopamine. And the dopamine release that comes with the music can help relieve their symptoms. So maybe like their hands will stop shaking more when listening to music. And this is because of music's really therapeutic effect of dopamine release. And while music therapy is mostly used in medicine right now, it could be beneficial to just about anyone. Um, Emotionally and getting rid of stress, music has been proven to help with that. So, music is a lot more of a medicine for the brain than people give it credit for. And this is still an emerging field, but I hope you learned something in today's presentation about music and the brain. Thank you.